Welcome guys to my next NX video. We're going to model a compressor disc. This one's a little bit more complicated than the ones we've done in the past. So if you've not looked at the ones I've done in the past, it's probably best to give them the once over first before starting with this one, because you might struggle with this one a little bit. Okay, let's start. Right, so this is what we're going to try and model. It's a compressor disc. I've taken some of the information off the drawing to try and protect the drawing a little bit. Some of the tolerancing's gone. There's enough information on here to model it though. So before trying to model something, it's always best to have a look at the drawing and try and understand the drawing if you're trying to model something that's already been drawn, for example. So this is a compressor disc model. We've got lots of slots in the outside running through it at an angle all the way around the outside. There's lots of holes in it and holes with features and things in it. So if we've got a hacksaw and we cut through this this model here and looked in the direction of these arrows, we would see this shape. So this is a compressor disc model with a drive arm on it. Have a quick flick through the drawing. So this is a section of the actual disc, and this is probably the starting point. Whenever you do any NX training, they normally say keep the sketches quite simple. However, in this case I believe it's better to model this as one sketch. So I would model this as one complete sketch and revolve it around the center line. So all these are diameters at these locations in this direction. They're all diameters and standard widths in this direction. So we've got some seal fins along here, which is shown in this view. The outside profile, which is shown in this view. Some of the drive arm detail in this view. So we need to go around the different views and check some of the different views as we're modelling and move around the drawing slowly. So basically what I'm going to do is start with this profile and try and model this as one complete sketch. So I think I'm going to start on datum A face, which is this face here, and I'm going to look at the detail that is shown in DJ. So it's this information here. So this is how I'm going to start my sketch, by replicating all of this. Right, so I think the best way of doing this is probably to zoom in on this and probably to have some of this open as well. So I think that's probably the best way of going around this scenario. So I'm going to have a bit of the NX open with a bit of the PDF file open. So let's start a new file. So here, because this disc model is quite large, what I'm going to do is I'm going to potentially create different versions of it. As I go through this particular sketch, I'm going to save different versions. So if something goes wrong, I can go back to a previous version. So I'm going to save it with this configuration on the end. Just edit the background. I think that makes it a little bit clearer. Right, just check to make sure the icons are the right size. That looks okay. So this should be able to come out okay when it's been put onto a video. Right, so I'm going to start by drawing this line in and this shape in. So let's go on home, start a sketch. So that's my first line, and this line can be this line coming through here. So I'm going to line it up with the coordinate system. So that could be my datum A face. I think I'm going to put in a circle. And a line. Let's just get rid of that, I don't like that. Right, so I'm going to make this touch this line. Actually, let's get rid of that line. Let's make that touch that line. Let's go tangency between that and that. Let's trim that back. I think it's better to put some of the smaller dimensions on first, so the lines don't start overlapping each other. So I'll probably start with these chamfers. So it's 1.5 by 45 degrees. Let's put this radius on. Right. I think it's always better to put the radiuses in as diameters and then put divided by 2. It's easy to type it in, less chance of going wrong. So that's the top one. And the best thing is on these sort of sketches is put a few dimensions in, a few constraints in, and generally just work your way around the sketch very, very slowly. So you've only got a few constraints at any one time. What you don't want to do is end up going all the way around the sketch and then you've got 500 constraints where you're trying to find. It's very, very difficult doing it that way. Right, so we've got 183.691 divided by 2. Right. Let's just move the line the right way. Let's go a bit. There we go. And then we've got from that line to that line 6.75. From there to there. Right, so basically what I've done, I've started doing a little bit of the sketch, put some constraints on it, and now I've just got 2 constraints required, the 2 ends. So now I'll go and draw a little bit more. Let's just extend that line. Just trim that off for now. And here I can use the chamfer tool. Don't like the fact that he puts these points in, so let's get rid of that. And this is 1 by 45. P15. And then we've got a thickness from there to there of 9. It looks like that bottom dimension's dropped off. So when I've taken that point out, that bottom dimension's dropped off. So I need to put that back in. So we've got 183.691 divided by 2. Right. Let's draw a little bit more. So there's a chamfer. Comes across and then up at an angle. That was P15. Here, 264.5 divided by 2. Right, let's draw a little bit more in. Always remember to click on the end of the line properly. Make sure this particular snap's on. The end point snap. Always make sure you've joined the lines up properly, otherwise when you finish the sketch you might have constraints outstanding and there might be little gaps in it where it won't want to extrude properly or revolve properly. Right, there's a little radius in there, little tool nose radius. Let's put some dimensions on. Divided by 2. Right, let's put that little chamfer on. So from there to there, P15. From there to there, P15. Right, there's a distance across there, 7mm. Let's make sure it does the right thing. Right, so what I'm doing here is I've just constrained that line to this coordinate system. So now I'm going to, when I do a dimension in this direction, I'm not going to come back to the coordinate system. I'm always going to come back to this line. The reason why is later on if I need to move this in relationship to the coordinate system, I can do it with one dimension. If I've dimensioned from here to here and from here to here, then later on I can't move this shape very easy at all. So that's why I've just done it the one constraint here to the coordinate system and then dimension everything else back to this. It's just easier. Right, there's some sort of radius in here, and there's a radius in here. I think we'll do that next. From there to there. Right, so it's done a few things here. Again, I've got some sort of intersection point which I don't like. It's not that dimension going to it. I think it's this one. Yeah, it's this one. So let's double click this one. Let's have a guess at that line with that line. Nope. Let's do an undo on that one. Let's try the bottom one. I want to move it to there. Right, so basically what I've done there is I've moved from this point to this point. So now I can delete this point and it won't delete that dimension. And it's got a tangency point there between this arc and this line, which doesn't want to be there either. So let's highlight that and delete it. You're better off fixing these things as you go through rather than try and do it all at the end. Right, so this line's being driven by a point. So I think we need to put a point in. So let's put a point in. Put it there somewhere. Let's go point on line. Let's put some dimensions on it. There's an angle in here of 40 degrees. I think I'll put that in first. And then from that point to that line, 20.725. No diameter. Right, so that matches what's on the drawing, and that matches what's on the drawing. I've got two constraints, and that's because it's the two ends of the line that we've not done yet. So that's looking good. Right, so I've done a little bit of work here, 10 minutes worth of work or something. I might want to save this now. So NX won't let you save while you're in a sketch, so you'll have to come out of the sketch and then save it. And then go back in the sketch. Right, let's draw the next bit that comes round here. Put the fillet in. And there's a red fillet here, and one here. Right. So from that line to that line. R5, this is R3. I can't see the other side yet, but I'm betting that should be R3 as well. So let's match it. Right, so that's about all I can see in this view. So we probably need to move to the next view. Let's have a quick look in this PDF, see what we can find. Probably this view we need next. Right. 48 across here. Right, so got two big radiuses in here next. I'm going to put a circle in. A circle. We'll join that up just by extending it. And this one wants to be tangent to that circle. So let's put tangency on. This one's not tangent, it sort of goes round like that, so I think that's okay. Let's trim back that line. Right, let's draw a couple of lines going up. Let's make this one tangent to that one. And let's make this tangent as well. And trim a few bits back. Right. So R75. Let's leave that one. We're going to height from there to there. That's now in the right place. If you see these lines are overlapping a bit, so I might just drag it a bit in the right direction. There we go. Right, so we've got a distance across here. There to there. 18.5. Right, so I think that's okay. Out the box, NX doesn't show you the it doesn't show you the decimal places. So I've just typed in here 88.825, and I'm only seeing, sorry, 55.825, 55.825, but I'm only seeing 55.8. So there's a way of changing that by pressing, I think it's Alt 4. There we go. So you press the Alt key and the number of decimal places you want. So if I go Alt 3, then I'm seeing the exact size that I want. So it's just a little trick as you're going around if you want to see the actual proper sizes. Right, this rad and this rad are the same rad, so it says both sides. So let's match it. Right, so we've gone rapid dimension again. It needs two constraints and it's the two ends of the lines again. So that looks pretty good. Let's do the next bit. So I think I'm going to work my way around this way, and then I'll probably save it. So let's put a line in. So it comes this way, down, across, up, across, up, there somewhere. So we're going to just draw a little bit in and then constrain it, put the dimensions on. It's probably best to put the rads and things in first, because then you can delete any points and things without deleting the dimensions. So it's probably a little bit quicker. So let's put in some fillets. You can use the fillet tool whenever it's tangent and tangent. Makes life easier than drawing circles in. Right. Looks like there's rods in here as well. Oh, sorry. Fill it there. And there. And then it looks like there's some chamfers on here. And we've got a chamfer in here as well. Right, so some of the information is missing now, so I need to try and find out where that's gone. Looks like it's in DF. Let's just go out of friction. Right. So this is the information we're after. Let's put some diameters on. So from here to here. 522.92 divided by 2. So I was a bit high. Looks like it's 5mm from there to there, but I'm going to put these little chamfers in first, which is basically 1 by 1. So we're controlling them with that P44. That's 5, and then we've got a dimension back to datum face A, which is here. Now I'm a little bit further this side than this line, which is wrong. This should be this side. So I need to move it first before I can put the dimension on. From there to there, that should be 23.235. Radius has gone a bit funny, it's because it's too big. So it looks like it should be 1.5mm. There we go. If you see, that's gone green around there now. So it's constrained properly. It's 1.5 in 2 places, so it's there and there. So I'm just going to match that one with that one. And then that should be 1 by 1. Let's give the diameter to that. and this should be over here somewhere. It should be this side of this line. So let's drag that over there somewhere. So that should be 11.235. And we've got a diameter to the underside of the seal fins, from there to there. Right, so again that's all gone green, which is good. So I think we'll put the seal fins in next, but before I do that I think I've got to save it. Let's go File, Save, Save As, and let's call it version 2. Let's edit that. Right, so let's draw the seal fins in. And the seal fins the design intent for them would be they're all the same. So I think I'll draw the first one in and try and drive the two right hand ones with the left one probably. Let's move that back a bit. Right, let's match the tops. And match the bottoms. Right. Parallel that one to that one. That one to that one. That one to that one. Right. So the seal fins are driven from a line 3/4 of the way up, which is going to be this line here. I don't want to constrain the ends of the line, so I'm going to chop the line off with this line and this line. I'll make this a reference. Right, so it looks like the thickness of these seal fins are controlled with a point from here to here, here to here. So I need to put a point in at these locations. There's already a point at the ends, so I don't need one at the ends. So if I go on point, what I want to make sure now is this intersection point is on, so it should put a point at the intersection of that and that straight away. There we go. Right, let's put the angle in. So from here to here. Actually, I think I'm going to go from there to there. That should be 20. So that should be 20 degrees. Let's make this one P58 divided by 2. Right. So I've got the angle in. Distance between that point and that point of 0.582. Okay. Right, so you have to be a little bit wary on the drawing. So we can model to the box dimensions, and we should always be modelling at mid-limit. So modelling to the box dimensions is okay, but you don't want to be modelling to the reference dimensions. The reference dimensions are just a reference, so you shouldn't really model to them. Right, let's go from there to the centre line. We'll zoom out a bit. You'll find your PC will slow down a little bit when this sketch gets quite big. Right, so we've got the tips, 540.99 divided by 2. Right, and let's put a diameter on this reference line. 539.39 divided by 2. Right. So that's looking good. So from that point to that point, P59. Right, and then from that point to that point, we've got 4.5, and from that point to that point. Right, so we're getting there. Now, it looks like it's that one that's constrained, so it's that point there. Back to the date. Right, let's put some rads in. Put some rads around here. Looks like the 1.2. Right, I think I'll control the first rad. And I'll match the rest. Right. So that's the seal fins done. Looks like there's a bit of a, it comes down a bit here. So let's just drag that back a fraction. Stick a circle in. And extend it. And it looks like there's a lower line after the fact. Looks something like that, and that's an R5. There's a drop there to there. .25. And then there's a distance from that point to that point. Right, so that's pretty much what that looks like on the PDF. So I think that's okay. It's all gone green again. Let's save that again. Let's edit it. Do the next bit. Right, what else we got? I think we'll do some of this next. So there's a line that comes up here somewhere. Cross. There's a fillet between there and there. There's something going on here as well. I think there's a separate line. I think that's too long. That wants to come down here somewhere. Some sort of circle. I think it's tangent there, and not tangent the other side. So it looks like that, I think. Let's trim that off. Extend. No, let's make that tangent first. And then let's extend it. I think it looks something like that. That's R15. Right. I see. This is dimension back to datum 8. And there's a dimension across here. From that point, center. There we go. Right, we've got 15 degrees in there. There's a radius in there and there. Let's put that in. This radius is 7.5. And this is datum B. From there to there. more in this side. So it looks like I need to move to the next sheet, this DH. Right. Right. That's weird. Why can't I find it? Ah, here it is. So that's the information we need, just here. .5 red. From here to the centre line. There's a rud in there as well. .3 mil. Let's put a dimension on from, let's do the little 4x4 first. Right. From that face to that face. I think that's on sheet 1. Yeah, 45 degrees. So from there to there. Right. So we're getting there. I think we'll look at that view again. And if you look, we've got two constraints, the end of this line and the end of this line. So we're not far away now. G. Let's have a look where that is. There we go. Oh, it goes a little bit out there. Right, so I'm a bit low with this. So I think what I'll do is I'll put this diameter here on next. Right, let's see if we can move that down a bit. There we go. Let's put this bottom diameter on. .393 divided by 2. Right, I'm missing some sizes in this direction. Let's see what else we got. So, and that's the wrong side. I need to move this across first. Just drag that line to there somewhere. I'll mention that back to datum A. There we go. So that's pretty good. So I've got some information here next. So it looks like there's a point on here somewhere. Let's put a point in. Make sure the right snap's on. So it's on that line. Let's put the angle in. this face. Let's put a diameter from there to there. Right, we've got two big circles on here that do the top. Need 3 constraints. Let's just save it. File, save as. Let's call it version 4. Right, there's 2 big circles going through some points. Big circle, big circle. Right, so we've got 3 points. Now we need to put diameters on all these points. Right, so we've got that one. Right, so that's the 3 points we need. Now I want this circle to go through this point and this point, and this circle to go through this point and this point. So let's go that one to that one, that one to that one. Yep. Right, so what we'll do now is I'm going to trim that back a bit. Let's trim back that and that. Let's put the radius on it. This is the 1500 one. Alright, so that's the first one. Now I need to put this one through this point and this point. Right, it could be difficult now finding out which line goes across which line, so I think what I'm going to do is I'm going to trim out this piece and this piece, so I know I've got the right bit at the front. Right, now I'll put the right radius on. There we go. Let's extend that up. Right, so that back end's correct. Now I need to trim that bit off. There we go. So we've got the two radiuses, that one and that one, and we're almost there now. Need to find out where the end of that's toleranced. Ah, there you go. So from there to there. Better. So that's controlling this end. I think there's a rad there we need. Let's have a quick look where that's located. 2.5. Right, I've just got this piece here to do now. So it looks like it's an R3. I'll try and blow that up a little bit more. There you go, so it looks like it's tangent at the top, but this dimension is driving the front of it. Something like that. Yeah. It's R3, and then we need to drive this position using that diameter. And sketch needs one constraint, so from there to centre line, and we've got 715.964 divided by 2. There we go. Sketch is fully constrained, so that is pretty much done, I believe. That's a copy of this PDF, so let's finish the sketch. Let's save it. And let's revolve it. So we need to revolve this shape around this x-axis. So let's go revolve. So we just pick the shape, middle mouse button, pick the axis. Ooh. Let's put a 0 on there. There we go. So that's the starting point of this disc. Right, so I think the next most difficult feature is probably doing the slots. So I think I would probably do the slots next. Right, so let's have a quick look at the PDF. Right, so this view on the screen is the same as this view here. Yeah, so that view there is the same as this view. And I can see around here that would be the seal fins running around here, which are these seal fins running around here. So if I did a section through here and looked in the same direction, it would go that way, and you would see the drive arm here on the left hand side. On here is on the left hand side. So if I did a section through this to match that and look in the same direction, let's go section, it would look like that. And that's the same way round as this. So I know that this is the correct orientation. Right, so the disc's in that orientation, and we've got a view looking down on top. So the disc goes down that way, it's third angle projection. And I think it's on the last sheet. So we've got this view here. So basically what we need to do is we need to replicate a plane through here at SLSL, and we need to draw this shape at this location. So if you look here, the slot going through the disc is going through here from this location to this location. So this 40.8 dimension is this 40.8 dimension here. So this line here is this line here. It's actually at that location there. Likewise, this line here is this line here. Okay, so right, so we need to put an axis probably at that location and put a plane through that axis. Let's blow that up a bit so we can see what we're doing. Right, so we've got a plane 66.725 from datum face A. So let's try and copy that. There's datum face A. It goes the other way. Let's go 66.729. Right, we're working at the top of the disc now, up here, not here, here, or here. We don't want to get mistaken and draw the slots in the wrong location. So I think the best thing is to move this plane where we're working up here. So let's drag this up. There you go. So that plane's offset from that datum face A, this 66.729. So I think I'm going to drop an axis in there now. So where it's got datum plane, got a little arrow, datum axis. If I select this plane I've just put in, and the plane going in this direction, that one. There we go. So I've got an axis now through that location. And now I need to put a plane running through there, through that axis. So let's go datum plane again. Click the axis. Ooh. And click the plane. Let's go 27 minus 27, 90 minus 27. That looks like it's the right way. Yeah. Right. You have to be careful these things don't snap onto anything, so let's just turn these off. Let's drag that up a bit. Right, so if you look there, that plane is across there. So we need to sketch on this plane. And what I'll do is I'll use this axis to be the center line. Let's just do a section through there. So that's the plane we want, and we need to draw the right shape at this location. Right, so that's what we need to draw. I think it's going to be quite difficult with this model in the background. It's going to keep snapping onto things if we're not very careful. I think I might hide the solid for now. Yeah, there we go. Let's hide the sketch as well. Sketch, hide. Right. Let's go back to home. Let's draw. Let's try and draw this shape. Right, so I think what I'm going to do, I'm going to start off with a line. That line can be this line here, back to the centre line. 33471. Right, then we've got the two flank angles. Something like that. Let's put in the angle. Right. I think I'm going to put a point. I think I'm going to trim that back to that line. Which will put a point on the end. And it will constrain the line. Let's change that to a reference. Right. And what you want to be doing here is copying the drawing dimensions rather than making up dimensions. Just trim that back to start with. Alright. And we've got some sort of radius at the bottom. Let's just draw a circle. Let's put the circle in the centre. And it's a radius. Circle in here somewhere, and here somewhere. Let's match the radius is. Make it tangent. Right, this is too far down because I've not put that dimension in yet. Let's put that dimension in from there to the middle of that. Um, 11.234. we go. Right, so that's sort of going as the shape we want. Now we need to go up, up, from there to there, 2.319, there to there, 17.8. That's okay. We've got a line coming across there somewhere. Just trim that back. And then we've got 2 points on our line. Let's put the angle in first. What angle we got? 15 degrees. Right. Let's trim that back so it's sitting on the line. Right, from that point to that point. Oh. 5. And then 32.437. From that point to that line, 9.783. Right, let's change that to a reference. Let's draw a line in, going up. Oh, still undo on that one. Didn't like that. That was strange. That's really odd. Shouldn't really do that. Let's try to do that again. Let's do it a different way. I think you should have done that actually. It's a bit strange that. Right, so it's done it now. Right, then we've got some rads. Here. One. Right, so from that face to there. And from there to there, 40.8. Need to put some rads in here, but this the length of this line just needs to clear the model So I can just put a high distance in here, just so it clears the model. I can extrude it in both directions. Let's go for 30, so it's plenty high enough with any minor tweaks we do to the outer surface. Right, that's looking good. Let's put in these little rads around here. So there's some fillets. It looks like 3.6 from there to there. She's fully constrained. Got some sort of point here again. Let's try and delete that so that one's one constraint. So it has deleted something. Let's try and find out what's gone missing. I think it might be from there to there. 17.8. There you go. Let's get you fully constrained. That looks pretty good. With making these two lines reference, NX will only see this shape. It won't see different volumes. It will see just one big area, which is what we want. So it's fully constrained, looks okay. Finish sketch. Right, so now I want to see the models, and I've currently hidden them. So I've shown it, and I've got a section on. There you go. So that's with section off and on. Let's extrude it. Should be able to pick just that shape. There you go. So let's go symmetric. Let's put in a big value that goes through. So that's pretty much what we're after. We want to extrude it in both directions, and here it's uniting it, and we want to subtract it. Yeah. Just hide some of the information. Right. So that's the first slot in. There's a couple of little things we need to tidy up. Let me just put a selection filter on so it doesn't highlight anything. Right, so we've got this bit here we need to tidy up. Likewise on the other side, we've got this bit here to tidy up, and at the back we've got bits to tidy up. So what we need to do now is we need to remove these bits before we instance it all round. Right, so I think to do that I'm going to do a sketch on this face and take that away. Let's draw a box. We ought to constrain this as well, but for now let's just see what we got. Yeah, that looks okay. Finish sketch, extrude, bit of the shape. Ooh. Right, so it's going in a funny direction here. It looks like it's actually normal to the surface. Let's try 15 there. Right, it's not quite. Probably getting all the volume. Let's try and move it in this direction. So specify the vector. Let's try. Nope. There we go. That looks better. you can probably see that it's now extruding in the right way, I think. Yeah, that looks okay. So I'm going to say subtract, that's okay. Wow, that's better. So that's one gone. Same on this side. Right. Something like that. So we're doing what we want. It's got the same vector specified. That's okay. Subtract. Done. Right. If you're trying to rotate the model around and it's rotating around the wrong axis, if you right click in the background, set rotation, then you can set to rotate it around a particular location. Makes it a bit easier to see what you're doing. That looks fine. That probably looks okay. There's a bit of a slither one there. We could probably do with trying taking that piece out, probably. Tidy it up a little bit. Let's try and do the same thing. Let's try and do a sketch on there, so we can turn that off as well. It's not going to let me select that face. Let's try that again. Check. Let's try and put a plane in instead. So I'll put a plane on that face at 0. Right, let's move the plane to the opposite side of the sketch. Right. Let's see if we can line that edge up with that plane. That's a bit better. Fraction. That's better. Right. Let's extrude that box. There we go. And it's already got in the right coordinate, the right vector. Subtract. That's better. Let's hide that. That'll do. Let's just hide that. Right. Right, so we've got the slot in now. It's looking reasonable. What we want to do now is we want to add them little bits to the cutout and then instance the whole lot. So we've got that extrude. If I hit the control key in a minute, I'm going to find out which ones I want. So it's that one, that one, that one, and that one. So that one. Right, so I'm going to hit the control key, select the extrudes that I want, right click, go feature group. It's already added the bits that I want into the feature group. I'm going to call it dovetail slot. So now the system's created a feature group with all them bits in. And how many have we got? That seems a bit strange. I think I've cut that information out the drawing, which is not going to help. Right. $34. So 34 off 360 divided by 34. Let's just hide that. Right. So we're getting there. Now we just need to put the holes and things in. Let's keep this so we can see it, so we know where we're working. We're working up here. Here's top dead center. Right. Let's put some of the holes in. I think we'll put these ones in first. One's going round here at this PCD. So it's these holes here at this PCD. So if I get my model the same way round, which is this way, sorry, it is that way, and that's at the top of the centre. Let's just minimise this a little bit so we can see the PDF at the same time, or what we're trying to do. Yeah, so again, they're the seal fins, they're the seal fins. So the sketch wants to be on this surface here. So let's do a sketch. And there. Oh, it's flipped it. Let's just flip it round. Right. It's at F8. F8 will straighten it up. Let's just draw a line in, I think. To there somewhere. Right, so that's obviously half the PCD. My first hole is going to be there, at top left centre. Sketch is fully constrained. Finish sketch. Let's go hole. There. Through body. That's okay. And it's 9.755. Right. F8. Right, so we've got 32 holes. And they're countersunk. Actually, it looks like they're only countersunk from this side. So let's just double click that hole again. Countersunk. So it's 90 degrees. Countersink diameter 11. There we go. Specify. What I want is that axis there. Just picked it. And we've got 32 off. Right. So let's put them holes in. Right, there's a series of 3 holes in this surface. Let's try and put them in next. Sketch, it's actually in this face. Let's flip it again. Let's go back. Right. I think what I want to do this time is I want to draw a circle in. Let's draw a circle in. Somewhere there. A line in. A line in. A line in. Right, so I've got 3 lines. We can touch the circle. And then let's put the PCD of the circle in. Let's see what that is. Looks like it's that one, 511.92. Not very far off. 511.92. 2.3 angle. P1121. Right, so I'm going to put the holes in there, there and there, and that matches what's on the drawing, but there's different holes. So we've got the two outer holes which are down to 7. Let's put them in first. Sketch is fully constrained. Finish. Just down to 7. There and there. I don't think that's quite what I want this time. Let's section it. Right. So if I left that on through all, it's going to cut through all of that, and that's not what I want. I just want these holes to go through this first piece. So let's go until selected. Let's pick that face there. Yeah, that's better. Right, then they've got a hole in the middle. Let's have a look what the hole in the middle is. So it's a threaded hole, 0.1932 UNGF. Right, let's go hole, threaded. If some of these settings don't appear, they're usually on here, you need to go more. So it was 0.19, quite small. Where are we? Oh, we're on the right one. There you go, UNJF. 0.1932 UNJF, yep, that one. That location. Not quite sure why it didn't select that then. That was a bit strange. Oh, wait a minute. That's because I either selected wrong. Let's try that again. Let's go threaded hole. UNJF 0.19. Let's click that. Let's just section it. There we go. Right. So we've got them 3 holes in. There's actually a countersink on that as well while looking at it. So, looks like it's just this side. It looks like the system's actually put the countersink on for us. It's just countersunk it to the maximum diameter. So we'll leave that. Right, so we've got the 3 holes. I think we'll add them to a group. So it's that one and that one. So that one, control key, that one, right click, feature group, and we'll call this one okay, and there's 24 instances, so there's 48 bigger ones, 24 little ones. Circular, right vector, X, there we go, and it's 24 off. Right, so we've put them holes in. Put the outer holes, put them holes. Let's put the drive holes in next. Right. Let's just hide some of the sketches for now. Right. Let's do a save on that. Right, so we've got these holes to do, and we've got these holes to do. Let's do these first. Right, so there's some information here, and there's some information here. Best if you can get all the information together normally. So these holes are going around here, and there's 30 of through the drive arm. So I think I'm going to zoom into that. Yeah. So this is what we need to do, these holes here. And these are at top dead center again. So let's do a section. So we'll do a sketch on that plane. Yeah, that one. So the holes we want are going to go through here. So, because it's quite a complicated hole, I think I'm going to draw it as a sketch. So it'll be easier to change later on for somebody. Right, so... Right, something like that. What we'll do now is I'm going to show the sketch, the very first sketch we did. I'm going to show that because I can now lock this line to this line. Linear, that line to that line, that line to that line. There we go. So this is going to be the centre line of rotation. .04 there to there. 45 degrees. Let's put the PCD diameter in. I think that was on sheet 1. So it's this one. 234.5. What else we got? Missing something somewhere. That's the diameter on that diameter there. And it was 12.65. Right, sketch is fully constrained, and that's the shape that's on here. That centre line is that line there. Finish. Put the shape. Right, Boolean, subtract. Okay. Let's hide that. And hide that for now. Right, that's the first hole put in. I think it was 30, yeah, typical 30 features. So I need to put that in 30 times. This pattern, circular. Let's pick the feature. 30. Specify the vector. Just have a quick look at sheet 1 to make sure what we've done is correct. 30 features, yeah, that's these ones here. Right, so now we've got the ones through the drive arm, and I think that's about it. So let's try and find out. Here's the information for that, and here's the information. So it's going through the drive arm here. Again, it's at top dead center. Right. Let's take a section. So we can do a sketch on the same plane. Yep, it's already picked it. Right, I think I'm going to do this differently actually. Right, I'm going to do this differently. Let's finish that one. I'm not going to put another sketch in for this. Let's get rid of that. Right, let's show sketch 1 up. I think what I'm going to do is I'm going to put a point in on sketch 1 instead. There's going to be there. Yeah, I'm going to use that point for putting this hole in. I've already got a sketch. Let's use the point from the first sketch. Right, so let's edit this one. Edit rollback. It's quite a big sketch, this one. Doesn't really matter though. It will do what we need. Point. Let's put a point in there somewhere. And let's put the point on the line. Point on the line. Let's go from there to there. And it should be 11.978. Right. Just double click that. And let's go for Alt 3. 11.978. Yeah. So that's the point. We just need to make sure we use this lower point, not the higher point. It's fully constrained. New sketch. The model's getting quite big now, so it takes a little bit of time to regenerate. There we go. Right, so I've got my point. It's that lower point there. Let's go hole. What we got? Down to 6. Just down to 6 through hole. So let's pick down to 6 here. Make sure you pick the point. Pick the point. It's not liking that for some reason. Let's try that again. Let's try that again. Hole. General hole. Down to 6. There. It's because, yeah, it's because of the depth. This is relying on the depth. Let's just go through body. There we go. And it's picked the fact that we're going the right way. Actually, the through body's not going to work there again because it's going to go through this piece here. Right. Let's go until selected. That surface. There we go. That's what we want. Down to 6. Right. Let's just take a quick section through there. Right, so there's a countersink on both sides to diameter 8. So it's a 1mm countersink. I think we'll just do that as a chamfer. It'll give us some sort of area here because it'll only be the right size at this particular section because this is slightly falling away from you, but it'll be good enough for what we need. So this needs to be 1mm. This is some sort of error because the surface is falling away from you. Ooh. And there. 1mm both sides. Okay to that. Right. So we look here. It's just an alert that's on this chamfer, which we already know about, because the surface is falling away from you. Right, so now we need to add 16 places equally spaced. So let's add the hole and the chamfer to a group. Give it a name. Right, so we've got that. 16 off. Right, so I think that's about there. Let's just unsection that. Let's hide that again. Let's hide that. Right, so that's our disc model complete. Let's just hide that. Right, so I think in the next video what we're going to do is let's just save this. What we'll do next is I'll do a quick drawing of this with all the dimensions that we've got from the PDF to prove that the disc model is correct to the original drawing, and we'll show you how to do some of the views that were done originally on the PDF drawing. Right, thank you very much for watching my video.